Hello. In this video we're going to take a look at finding some derivatives using the power rule, constant multiplier rule, or the sum and difference rule for derivatives. So the power rule for derivatives says that if we want to take the derivative of our variable raised to a power, that we're going to bring that power down as a coefficient times our variable raised to the power minus 1. Constant multiplier rule tells us that if we have a constant times something we know how to take the derivative of, that derivative is going to be the constant times the derivative of the function. And then the sum and difference rule says that if we have two functions added or subtracted together, we can take that derivative by looking at each term individually and taking the derivative of the first term plus or minus the derivative of the second term. All right, so let's take a look at this first example here. We have f of x equals 13x squared plus 10x to the negative 3 minus 8x to the 4.6. So if we want to take this derivative, we can use the sum and difference rule and look at each of these terms individually. And then we can use the constant multiplier rule to pull those coefficients out front, and then use the power rule to take the derivatives of those powers. So our derivative, f prime of x, is going to be equal to 13 times the derivative of x squared. X squared is using the power rule with n equal 2. So it's going to bring down that power of 2 times x to that power minus 1. So 2 minus 1 is 1. And you don't necessarily have to put that 1 there. It's an understood. Our second term, again, we're going to pull that coefficient of 10 kind of out front and not worry about it for just a minute, and then use the power rule to take the derivative of x to the negative third. That means that we're going to have negative 3 times x, and then pay attention to your signs here. Negative 3 minus 1 is going to be a negative 4. And then our last term here, we have negative 8x to the 4.6, so we'll pull that negative 8 out, and then the derivative of x to the 4.6 is going to be 4.6 times x, and then we're going to subtract 1. 4.6 minus 1 equals 3.6. All right, now let's clean that up just a little bit. 13 times 2x to the first is the same thing as 26x. 10 times negative 3, x to the negative 4. Let's go ahead and simplify that completely and go ahead and write that negative exponent in the denominator. So we'll get negative 3 times 10 will give us negative 30, and then x to the negative 4th is x to the 4th on the bottom. And then our last term, negative 8 times 4.6 is negative 36.8 x to the 3.6. And that would be our derivative for that first function. All right, let's take a look at another example. All right, our next example, we have f of x equals 3x squared minus 5 over x plus 2 times the cube root of x plus 4. So the first thing we need to do is to get this into the form that we saw the previous one, because our power rule only works if we have a coefficient times x to a power. We cannot have that x in the denominator. So before we take our derivative, let's go ahead and rewrite this in that form. So we're kind of doing the opposite of what we did on this last step for our middle term. Instead of writing that x squared in the denominator, we're going to write it as a negative 2 power in the numerator. Same thing's going to happen with 5 over x. We're going to write that's x to the first in the denominator, so that means x to the negative 1 in the numerator. And then if we have any kind of root, doesn't matter what that root is, the nth root of something can be written with a fractional exponent, 1 over that power. So the cube root of x is going to be the same thing as x to the 1/3 power. And then here we can kind of think of this as 4 times x to the 0, because remember x to the 0 is 1. And so 4 by itself, a constant, is going to be 4 times x to the 0. So now we have this exactly how we want it to look. And Our derivative is going to be 3 times x to the negative 2. Bringing that power rule down, we're going to do negative 2x. We're going to subtract 1. Negative 2 minus 1 is negative 3. And then we get negative 5 times the derivative of x to the negative 1 is going to be negative 1 times x to the negative 1 minus 1 is negative 2. And then we get 2 times the derivative of x to the 1/3 is going to be 1/3 times x. If we do 1/3 minus 1, 1/3 minus 1, we'd have to get a common denominator there. So we can think of that as 1/3 minus 3/3, which gives us negative 2/3 as our new exponent. And then we get 4 times 0 x to the negative 1. So we get negative 6 for our first term. X to the negative 3rd is going to be x to the 3rd in the denominator. Negative 5 times negative 1 gives us a positive 5. X to the negative 2 is x squared in the denominator. 2 times 1/3 is going to be 2/3, and then x to the negative 2/3 is going to be x to the positive 2/3 in the denominator. And I would recommend leaving it in that form. You could, if you wanted to, write it back in the cube root form. That would be the cube root of x squared, but you can leave it like that as far as the algebra is concerned. And then here we've got 4 times 0 over x, and anything times 0 is 0, so that last term is going to go to 0, and so our answer is just going to be the first three terms. All right, I'll see you guys next time.